Adverse effects can literally make or break your program. Today we're talking about how we decide whether a finding in a tox study is adverse or not. So I have a little flow chart here that you can see, and we're going to go through it. There are typically about 5 things you can see here that we use to decide whether an effect is adverse. And when we talk about an effect or a finding, we're talking about a test article related finding. So within a tox study, you might have no findings. You might have some findings that aren't test article related. They might be just a smaller incident or species specific or animal related. And then we have test article related findings that are directly related to the drug. The drug is causing these effects. And then we have adverse effects, which means that those effects that the drug is causing are adverse enough that it alters essentially the physiology and the biological function of that animal. And so adverse effects are what we use to determine NOAELs, and that correlates with our exposures, which correlates then to how we determine our starting dose in the humans, and then ultimately how we determine if our drug is safe enough to go into humans by using, adequate margins and understanding where that safety fold lies. There are other videos that I have out there on Nonclinical Academy on YouTube that talks about TK profiles, exposure, interpreting findings, things like that, so check them out. But today we're going to focus on adversity and how we decide with the study director and or the pathologist what findings are adverse. And figuring out which findings are adverse really is a conversation, is a discussion between the sponsor, which could be you, the CRO or the study director, which also could be you, depending on what your role is, the pathologist, which would be you. And so it's really a discussion about how we would decide what's adverse, what's not adverse. And there are a lot of different papers and literature out there that discuss this as well. But we'll go through this flow chart. This kind of breaks it down into a simpler flow to understand what we're thinking about, why we're thinking about that. So let's start at the top, right? A finding came back in your study, and we're going to ask these questions. Is there a dose response? Question number 1. Basically, is that finding become more severe as dose increases and as exposure increases, or is it a flat response where the finding, you see it across every dose? And so if there is not a dose response, then it's likely not adverse. There's no dose relationship. It's usually incidental. Document it and sort of move on. In the cases that this is not adverse would be if it's a one-off finding. You see 2 animals in the mid-dose that have it, or you see 1 animal in the low dose, 1 animal in the high dose, and there's no dose response. There's no linear connection between the findings across doses. The finding itself doesn't increase in severity. It doesn't increase in effect. And so that's when it would likely not be adverse. When it would be adverse is if there's no dose response because it is a very toxic, potentially fatal finding at all doses. That kind of flat dose response, that's a clear adversity. So let's say that there is a dose response, right? So we see this finding increasing in severity across increasing doses. So we're going to go down to the next one. Is it reversible in recovery animals? If it's not reversible in recovery animals, then it's likely adverse. Full stop. Typically what happens is we'll dose animals in life for a certain duration, and then we'll stop dosing after, for example, a 28-day study, we'll stop dosing at day 28, and then we'll go into a recovery period to see if there's any findings that we saw in the dosing phase, if those continue in recovery, and if those are reversible, meaning that those findings actually go away. If they don't go away, then this is likely adverse. So non-reversible findings are a serious regulatory signal. The FDA will absolutely scrutinize your clinical dose. Say you have an enlarged liver with elevated liver enzymes, and that doesn't recover in your recovery animals, meaning that dosing has stopped after 4 weeks, those livers are still enlarged, and you still have elevated liver enzymes. That's a clear liver toxicity response, and that's something that the FDA is definitely going to flag. So that would definitely certainly be adverse. Okay, so is it reversible in recovery animals? Yes, it is. Okay, so is there histopathological evidence? This is something that we take very seriously in terms of that you could have elevated liver enzymes, but no histopathological changes within the liver. And this lack of correlation usually means that a finding may not be adverse. Now, there are different scenarios. Every program is different. So if you have elevated liver enzymes, that increase in severity, like we said, overdoses, then that could potentially be an adverse finding. But if you have some elevated liver enzymes that don't correlate to any enlarged liver, there's no growth path findings, there's no histopath findings, and no changes in the tissues, then this could just be adaptive. Could be something that is a discussion, likely a discussion, of whether or not you would call that. It's definitely probably pointing to liver toxicity, but whether you would call that adverse versus just test article related, that is a conversation that you're going to have with the study director and the pathologist, so everybody can kind of weigh in together. So moving back down to the chain, is there histopathological evidence? Yes, there is. So then we move back down. Is the magnitude biologically significant? So if it is not biologically significant, then it's likely adaptive, meaning the animal is just basically compensating. The animal is doing what it needs to do to be able to adapt to the changes that are happening based on the drug. These are usually small, within normal variability. They have a known background. You can document the rationale. This also is where historical control data comes into play, meaning that if you have a finding that is not biologically significant and it is likely adaptive, it's likely because you're able to show that it's within the normal range of that animal using historical control data. And we use this a lot, especially with the tox species that we have. There are a wide range of databases out there for historical control data. And so if we have a finding in a particular animal in a particular dose, we can go back and look and see, okay, what's the normal range that this finding would be found within this species and or sex of the species. And if it's within that range, then we wouldn't typically call it a drug-related finding or even adverse, because it is just part of the species biology. Is the magnitude of the finding biologically significant? Let's say yes, it is. We'll go down to the last one. Is it consistent across sexes and or species? This is a big one. This is probably one of the most major ones, aside from a dose response and or correlation. If it's not consistent across sexes or species, then you can do a little bit more investigation. It could be species specific, it could be sex specific, it could be exposure differences that are causing this. However, if it is consistent across sexes and species, that's a big indicator that it's an adverse effect, that it is going to be translatable to humans. And that's why it's so massive, is that its translational strength increases if you see it across males and females, and if you see it across rodents and non-rodents, then that is definitely an indicator that you're probably going to see it in the clinic, and you have to be able to mitigate that, whether that's mitigating it through dosing and exposure, mitigating it through clinical monitoring. But you can see that, yes, it is consistent across sexes and species, then it's an adverse finding. You want to document it, characterize it, and build your safety argument around it. And now, note here, even with this flow chart, right, if you have an adverse finding, that doesn't mean that your program is dead. That doesn't mean that your drug isn't going anywhere. That just means that you have to understand and justify, one, why is it adverse? Where is it becoming adverse at? You know, what exposures are driving it to be adverse? Is it exposure? Is it Cmax driven? Is it species specific? There are a lot of species specific findings that are adverse that don't relate to humans. They're irrelevant to humans. Understanding that justification is critical. And so an adverse finding, yes, it drives your NOAEL, it drives your animal exposures and your exposure margin, and it drives your human starting dose, and the implications within the clinic in terms of clinical monitoring and your clinical protocol. But it's not the end-all be-all of your program not being able to move forward. Ultimately, what you want in a tox study is you want tox. You want toxicity. That's how we understand where the ceiling is, to be able to understand where we can go and how we get there in the clinic. And so having an adverse effect, that's how we find our NOAEL. If you don't have any adverse effects and you don't have a NOAEL, then your NOAEL will be above your high dose, essentially. And it's not necessarily that you didn't dose high enough to find it. You might not have an adverse effect if you have a safe drug. This is sometimes very common with biologics. But being able to understand then what findings are drug-related, test article-related, and what those exposures are, and then potentially being able to understand if there is a range of exposure that would cause these effects to be more severe, that would potentially go into adversity. But as long as you've built your program around a well-justified sequence of studies, meaning that you've run your PK, then you've run your non-GLP, you did a well-designed, well-executed MTD study and or DRF study. You chose your doses, you narrowed them down for your GLP, you ran your GLP studies, you executed it well. As long as that is all justified and you can thoroughly put together a defensible regulatory narrative, that regulatory story, then you should be in good hands. This is something, as long as the science is there, as long as the science is sound, you might not necessarily have adverse effects on a study, but if you do, it's something that warrants a discussion, particularly with the study director, the CRO, the pathologist, the sponsor, and then ultimately with the FDA within your IND or any regulatory agency that you submit to. So this is all about adversity, and we do a much deeper dive into my course, The Complete Guide to Non-Clinical Development. I'll pin it here. You can also click the link in the description